Hello friends, welcome back. In this video we are going to study some more examples of the coordination compounds which are named by using the IUPAC nomenclature system. So let's start with this. Let's take the examples. So we are having the next example, that is CONH3 thrice NO2 thrice. Okay. So how to name the coordination compounds? First of all, let us write these structures. In this structure, we know that this cobalt is the central metal atom, and this cobalt is attached to the ligands. So for this, we require the oxidation state or the oxidation number of the central metal atom. So we should know the nature of the ligand. That means whether it is a neutral ligand, positive ligand, and the negative ligand, and then we should know the charges. Okay. So let's see that we are having this NH3 that is the ammonia. Ammonia is the neutral ligand, therefore it is having a zero charge. Then NO2, that is a nitro is the negative ligand, therefore it is having a -1 charge, right? So from this we can find out the oxidation state or the oxidation number of this cobalt. So the oxidation state or the oxidation number of the cobalt becomes +3. Okay, then how to write the name? While writing the name, the ligands they are arranged alphabetically, right? So let's write the name. The name of this compound or the coordination compound is triamine. Now here there are two ligands, ammonia and the nitro. This ammonia comes before nitro, that's why we have taken the triamine. Then again there are three nitro, therefore it is a trinitro. The metal is cobalt with the oxidation state +3. So it is a name as triamine, trinitro, cobalt +3. Let's take the next example. It is Na3AgH2O3 twice. Now this type of the complex, it is an example of the anionic complex. Why it is anionic complex? That means this complex which is in the square bracket, it should have a minus charge. When it is having a minus charge, when outside ion is the cation. So here there is a sodium. Sodium is a cation, it is having a plus charge, that's why the complex should have the minus charge. Therefore it is called as the anionic complex. Now in this anionic complex, this silver is the central metal atom. Then this ligand H2O3 is the negative ligand which is having the -2 charge. For one H2O3 there are two H2O3, that means it is having the -4 charge. Then outside the square bracket we are having the sodium which is a cation which is having a +1 charge. For one sodium, as there are 3 sodium, it should have the +3 charge, right? As it is having a +3 charge, the complex should have the -3 charge. So the oxidation number of the silver becomes +1, right? Now how to name the anionic complex? While writing the name of the anionic complex, first of all we have to write the name of the cation, that is the sodium. Then full name of the ligand. Then we have to keep a space between them. Then we have to write the name of the metal with the ending ATE, and then without any spaces in a bracket we have to put the oxidation state. So its name is sodium bis. Why it is bis? Because it is a polydentate ligand. Sodium bis thiosulfato argentate +1, right? It is sodium bis thiosulfato argentate +1. Let's take next example, NiDMG twice. So in this NiDMG twice, nickel is the central metal atom, DMG is the polydentate ligand. Its charge is the -1 because it is a negative ligand. As there are two, therefore the total charge becomes -2, and hence the nickel should have the oxidation number +2. So what is the name? Its name will be bis because it is 2, therefore it is a bis dimethyl glyoxymato. Bis dimethyl glyoxymato nickel +2. Bis dimethyl glyoxymato nickel +2. Let us move on. The next one is the NH4 twice PTSCN6. Again it is an example of the anionic complex. So let us see the charges. This SCN is the negative ligand which is having a -1 charge. As there are 6 SCN, therefore total charge will be the -6. NH4 is the cationic, therefore it is having a +1 charge. There are two NH4, therefore it will be having a +2 charge. That means the complex should have the -2 charge, right? So the oxidation state becomes +4. Therefore the name, first of all we have to write the name of the cation. Cation is the ammonium, then the full name of the ligand, hexathiocyanate-S. Then in between these two we should keep a space. Then metal with the ending ATE, that is the platinate with the oxidation number 4. So it is ammonium hexathiocyanate-S platinum +4. Next one, again it is the same, that is the anionic ligand, NH4 in the brackets CrNH3 twice and CS4. So in this complex, chromium is the central metal atom and these are the ligands, and outside this complex we are having the ammonium, that is a cation. So the charges, NH3 is the neutral, therefore 0 charge, NCS is the negative, therefore -1 charge, NH4 is a cation which is having a +1 charge. As there is one NH4 which is having a +1 charge, the complex should have the -1 charge, right? So the oxidation number becomes +3. So while writing the name, first of all we have to write the name of the cation, that is the ammonium, full name of the ligand. So the ligands are tetraisothiocyanate, then a diamine chromate +3. Okay, it is so ammonium tetrathiocyanato diamine chromate +3. Next one, it is CONH34NO2Cl, Cl4. So in this complex, this cobalt is a central metal, ammonia or the NH3 neutral, therefore 0 charge, NO2 that is nitro negative ligand -1 charge, Cl chloro that is -1 charge, and outside this square bracket we are having the ClO4 which is having the -1 charge. As it is having the -1 charge, the complex should have the +1 charge. So the oxidation state becomes +3, right? So what will be the name? While writing the name, we have to put the ligands alphabetically. Then we have to write the metal with the oxidation number +3 and then ClO4, name of the ClO4. So it is a name as tetraamine chloro nitro cobalt +3 perchlorate, right? Tetraamine chloro nitro cobalt +3 perchlorate. Next example, K4NiCN4. The same, that is the example of the anionic complex. Again in this, the nickel, that is the Ni is the central metal atom, Cn that is a cyanide, it is a negative, therefore having the -1 charge. There are 4 Cn, therefore total charge becomes -4. Potassium is a cation +1. For 1 potassium there are 4 potassium, therefore total charge becomes +4, and hence the complex should have the charge -4. So the oxidation number of the nickel become 0. Hence the name, first of all name of the cation, that is a potassium, full name of the ligand, that is a tetracyano, then the metal with the ending ATE, that is a nickelate, and the oxidation state 0. So it is potassium tetracyano nickelate 0. Next example, CONH2NH35SO4. In this, cobalt is the central metal, NH2. NH2 is the negative ligand which is having a charge -1. NH3 is the neutral ligand, total charge is 0, and outside the square bracket sulfate SO4 which is having the charge -2. As it is having the charge -2, the complex should have the charge +2. So the oxidation number becomes +3. So the name is pentaamine, as there are 5 ammonia, therefore it is pentaamine, then amido cobalt +3 sulfate. It is pentaamine amido cobalt +3 sulfate. Next one, K3FeCN5CO. In this, it is an example of the anionic complex. The Cn negative ligand, therefore -1 charge. Carbonyl neutral ligand, therefore 0 charge. potassium cation, therefore plus 1 charge. On the complex ion there should be minus 3 charge, hence the oxidation number is the plus 2. So the name is, first of all we have to write the name of the cation, that is the potassium, then ligands carbonyl, then pentacyano, metal with the ending ATE, therefore it is ferrate, and the oxidation state plus 2. So it is potassium carbonyl pentacyano ferrate plus 2. Next one, AlOH H2O5 plus 2. In this example, aluminium is the central metal, hydroxo or the OH is the negative ligand, therefore minus 1 charge, water H2O is the neutral ligand, therefore 0 charge, and on this complex it is having the plus 2 charge, therefore at the end of the name we have to write the ion. So the oxidation number is the plus 3. Therefore the name of this complex is the pentaquo. As there are 5 water molecules, it is pentaquo, then hydroxo, aluminium with oxidation state plus 3, and then ion. So it is pentaquo, hydroxo, aluminium plus 3 ion. Next one is the Cr NH36NO3 thrice. In this complex or the coordination compound, chromium is the central metal, NH3 is the neutral ligand, therefore charge is 0, and outside the square bracket we are having the NO3 which is a negative, therefore having the charge minus 1. As there are 3 NO3, therefore total charge becomes minus 3. Therefore the complex ion should have the charge plus 3, and hence the oxidation number of the chromium is plus 3. Right. So the name is, it is hexaamine chromium plus 3 nitrate. Right. Hexaamine chromium plus 3 nitrate. Next one, Cu CH3CO CH2 CO CH3 twice. Right. Now in this complex, this copper, that is Cu, is the central metal atom and this is the ligand. What is the name of this ligand? CH3CO, CH2CO CH3, and it is 2 times. 2 times it is a polydentate ligand, therefore we have to use the prefix bis, and it is a negative ligand. It is a name as acetyl acetonato, which is having symbol ACAC. Right. So it is a negative ligand, therefore which is having the charge minus 1. As there are 2, therefore we should have the total charge minus 2, and hence copper should have the charge plus 2. Therefore the name is bis acetyl acetonato copper plus 2. Next one, PT, that is a platinum, PT NH34NO2 ClSO4. Now in this coordination compound, platinum is the central metal, then NH3 is the neutral ligand, NO2 is the negative ligand, therefore minus 1 charge, chloro is the negative ligand, minus 1 charge, outside the square bracket sulfate which is having the minus 2 charge, complex should have the plus 2 charge, and hence the oxidation number is plus 4. So the name is, it is a tetraamine chloro nitro platinum plus 4 sulfate. So it is tetraamine chloro nitro platinum plus 4 sulfate. Next is, so next example is, it is an example of the bridging type of the ligands, and we know that bridging ligands means the ligands which are shared by 2 different atoms or 2 different metals. Right. Now here there are 2 carbonyls. This is the first carbonyl and the second carbonyl. These 2 carbonyls, they are bridged, they are shared by the 2 Fe atoms. Therefore these 2 carbonyls, they are known as the bridging ligands. And while writing the name of these bridging ligands, we have to use the prefix mu. Okay. So which are the ligands in this? In these ligands we are having the 4 carbonyls. This is the first carbonyl, second carbonyl. These are not bridge carbonyls. Whereas these 2 carbonyls, they are the bridge carbonyls. Along with this, we are having the C5H5 to one side and C5H5 to the another side. So let's write the name. It is bis. Bis means it is a polydentate ligands. bis cyclopentadienyl. This C5H5 is known as the cyclopentadienyl. There are two, therefore it is a bis cyclopentadienyl. Then these two carbonyls, they are written as dicarbonyl. In the bridging carbonyls, they are named as mu dicarbonyl. Then there are two ions, therefore di-ion with the oxidation state 1. Okay, so it is a bis cyclopentadienyl dicarbonyl mu dicarbonyl di-ion plus 1. Right. Let's take next example of the same bridging type of the ligands. Now here the bridging ligands are different, right? And on the complex ion it is having a charge +2. Therefore at the end we have to write ion, right? Then it is having NH3, 4 NH3 at one side and 4 NH3 at another side. That means total 8 amine ligands or the ammonia ligands. There are two metals which are the cobalts and the bridging ligands. One is the NH2 and another is the NO2. We have to put them alphabetically. So the name is mu amido. NH2 is the amido, therefore it is a mu amido. NO2 is mu nitro octa. Octa means 8. 8 amine. Then there are 2 cobalt, therefore dicobalt plus 3 ion. So it is a mu amido, mu nitro octaamine dicobalt plus 3 ion. Let's take the next example. In this example, there is only one bridging ligand, that is the NH2. And the two metals, they are the cobalt and it is attached to the 5 plus 5, total 10 ammonia ligands. And outside the square bracket, we are having the 4 NO3. So its name is mu diamido. There are two amido groups which are bridged, therefore it is a mu diamido. Then deca, deca means 10 decaamine, then 2 cobalt, therefore dicobalt with oxidation state +3, and outside the square bracket it is nitrate. So it is a mu diamido decaamine dicobalt +3 nitrate. And the last example of the bridging type of the ligands. In this bridging type of the ligands, we are having the NH2 at 1 and OH, that is hydroxo, that which is the second bridging ligand. These are the two bridging ligands. There are the metals which is the cobalt, and the other ligands are ethylene diamine. 2 ethylene diamine to one side and 2 ethylene diamine to the another side. That means there are total 4. And for the polydentate ligands, we are using the prefixes tris or the tetrakis or the pentakis, etc. And outside the square bracket, we are having the sulfate. So the name is mu amido. This NH2, which is a bridging, therefore it is a mu amido. For the hydroxo, it is a mu hydroxo tetrakis. That means there are 4 polydentate. Therefore it is tetrakis, ethylene diamine, then dicobalt plus 3 sulfate, right? It is a mu amido, mu hydroxo tetrakis, ethylene diamine, dicobalt plus 3 sulfate. So these are the examples. In the last video and this video, we have studied the various examples of the coordination compounds, and these coordination compounds, these are named by using the various rules of the IUPAC nomenclature system. Okay, thank you.